All right, doing some field work on this one again today. This is actually the second car I'm working on. The last one that I did here was the Lincoln Continental. Now it'll probably be maybe a week between videos before you guys see this one, but just so you guys that are following along, this is the second one I'm doing. It's nice when you do the mobile stuff. You work for a garage and they line up the cars for you. You come to one garage, you don't have to travel around a lot. It's a good way to make money. So this is a 2002 Pontiac Grand Am with a 2.2. It's another no start. Right away we're going to approach this one differently. Main reason for that is because of the ignition design. The ignition design on this one, the coils are inside of here. I can't easily remove a spark plug just to check for spark and see what we're missing. Easy fuel pressure check. We may start with fuel pressure on this one, but I'm going to take you inside and we'll grab a shot on the scan tool. And got a ton of glare. I'm in the sun. So let me try the desktop recording. I'll leave you guys focused out here. First thing I need to do is ID the vehicle. Pontiac. It's a 2002 Grand Am with a 2.2 Ecotec engine. And this is a 4-speed auto. Going to my engine. No key required. I already have the connector on there. Going to my trouble codes. Looking for some help. Got a cat code. That's not going to help me. I mean, unless the cat's totally plugged, but normally an efficiency code is just that. It's efficiency. It's not restriction. Yeah, just got cat code, so that's not going to help me. This Ecotec system uses a synthesized cam sensor. So there's only a crank sensor on this. Not that that's where our problem is. I need direction. I need to figure out where I'm going. Let's see if we get an RPM signal on this one. We tried this on the Lincoln. We didn't have an RPM signal. And I'm going to customize this, deselect everything, just pick my RPM. So I want to speed up this data process, and I'm going to crank it. All right, you see on this one, we have an RPM signal. So that's a great direction test. It's not foolproof. It's great in the case for this one because I know I have a crank signal. And this really dictates my next step. I have a crank signal. Most likely I have spark. And my guess is I'm missing fuel. And I don't know for sure. I could be totally wrong. But I'm going to go after fuel first on this one because I have a good RPM signal during a crank. So fuel pressure, right? Why are we doing fuel pressure? It's easy to do. It's right here. If I didn't have a Schrader valve available to me, would I maybe go in another direction? Yeah, possibly. Our mindset always needs to be, what is my next easiest step? I think you guys would agree with me there. How can I find out what's wrong with this car as fast as possible? I didn't get any fuel at all when I connected this. My guess is we're on the right track here with fuel pressure. I have no residual pressure at all. I'll keep you guys focused on the gauge, and I'll jump in it and crank it again. That should be good. I know the gauge is a little off set, but you know, there's 0 right here. I got about 7 pounds of pressure in there right now. 40's over here, which is probably about where we're supposed to be on this. All right, cranking it. Okay, it almost wanted to start that time, didn't it? And our pressure is really low. You know, I wish I would have seen that pressure. You guys saw it, but I don't know what it was. So cranking that, I'm guessing it didn't rise any higher than 7. what I need to do to make sure that it didn't rise higher and then bleed right back off. I need to see that myself, and I'm just gonna move this for a second so I can see it. You guys are gonna miss this last crank, but I missed the other one, so I need to see this number. I'm pretty sure that it's staying on that 7 PSI number. Yeah, it kind of wants to run, which makes sense. We're definitely into a fuel issue, no question about it. Right off the bat, we have a pump issue, whether it be power, ground, or the pump itself. You know, most likely this is going to be a pump. Do we want to be 100%? Absolutely. Is this about guesswork? It sure isn't. I've done enough of these that I've seen many different wiring problems on many different cars. It is worth the extra 10 minutes, 5 minutes, whatever, probably 15 because I'm filming, but extra 5 minutes if I'm not filming to check this pump. I'm really right now just looking for the pump relay in this distribution box. Just make sure you guys can see what I'm trying to do here. I just pulled the box off. Nice, the GM marks these for us, and I'm looking for the fuel pump relay, and it's 18. 18 is my pump relay, which is going to be this guy in the middle, which is this guy right here. And funny, someone has marked this relay. Check it out. Pontiac Grand Am. Somebody wrote on the relay. Let's see if that's showing up. Look, right? Somebody threw a relay in this already. Cool. All right, so I want to do an amperage measurement. You guys have seen me do this before. I'm gonna grab my tools to do that. All right. Tool I'm using, which is starting to become a favorite of mine, is this little U-Activate tool that I got from AES Wave. And what I'm going to do, you guys have seen me use this before. Some of you have. Trying to think of some of the videos I did this in. Causes and symptoms of low fuel pressure. There was a 2-part video. That's where I use this tool in that one. And it's a pretty neat tool. Not really going to worry about going over the tool overview. Really what this allows me to do is just connect to this pump circuit and really activate it independent of the car. I mean, I may need the key on for power on this circuit, but primarily I wanted it so I could put my amp clamp around here. And I know there's other ways to do it, but safety is an issue here. You jump the wrong pins on this connector down here, you have the potential to fry the engine computer. So be careful what you're doing. All right, key is on. And what I don't remember about the tool is if that light comes on or not. The other thing we can do, these are the test ports, so I can check for voltage here. I need to do that. So I'm a little bit nervous about what I'm seeing so far. Just using my old school Vantage again to give me a voltage reading on this circuit. I go to a ground and then check for voltage on another pin, just making sure that I got 12 volts on that. This is tough to do. It's tough to do both of these at once. Is that showing up? Man, using a different tool. This old Vantage doesn't do well on the camera. It really doesn't for me. See, I can see that though. You should be able to. All right, look, you're just gonna have to take my word for it. I hope it shows up. I'm reading 12.32 volts on this right now. That's just putting my meter to a known good source. And there's actually a fuse missing that bothers me. What fuse is that? That is 43 is missing. Fuse 43 is, the horn fuse is missing. Okay, don't care. All right, so I have this tool connected, and I know I could check them on the car too, but I have the tool. I want to use the loop for current, and I just want to make sure that I have what I need on the control circuit. And now the control on this is, it's not going to be powered unless I crank it. That'd be on this one. I'm reading 1.81 volts on that, and then I'm reading 0 on that one. These are power side switched on these, and I believe that that's a bias you're looking at, that 1.81 on this side. Let me switch this for a second. See, I'm not sure. Then this would be load side, I guess, up top. Yeah, maybe, huh? I just want to make sure that I'm switching this on. Okay, cool. All right, my perspective is a little skewed on the tool. All right, listen. The tool actually gives me test ports too. The area in here, the control, is when you crank this over and the computer would be controlling the relay if the relay was in place. And what the control does, this gives you test ports. I believe it's going to light this light whenever the computer turns the control side on. And then the load side, there are the contacts out here. That'd be these guys. And if you look at the meter, when I go to the green side, you see I got 12.32. Hopefully you can see that. It's 12.3. And then I go to the red side and I have nothing, which is what I expected. In fact, I can just, that's cool. I can just put my port. See, you learn new things all the time. I can just put my lead in there. That's kind of cool. 12.3 volts on the load. That'd be my load side feed. That makes me feel good. And then I go load side control. I'm reading 0 volts. And then when I hit the switch, I am feeding voltage to that pump. It's 10.4 whenever I turn that pump on. And let's see if my load side's dropping to that. No. Why is that such a drop in voltage? 12.3. And then on the load side of this, it's 10.5. So there may be some resistance a little bit in the tool. That's not a problem though. 10 volts is enough to turn that pump on. And that should be enough for me to get a test, but I don't like that voltage being that much different. 12.3 and then 10.4. Well, let's get an amperage measurement on this and see what we got. All right, using an inductive low current probe. Changing my scales to a 1 volt scale. 1 volts is 10 amps on this ammeter that I'm using. Okay, so I'm set on a 20, which is 100 millivolts is 1 amp, and I'm going to clip around my tool here just like that. I'm going to measure the pump current, flick my switch on. I got no current flow here at all, and that would be as noted by my Vantage. Let me get you zoomed in on that just in case you can't see that. I'm thinking you can. I just got a really small screen here. So we've done this before, haven't we, guys? Right? Click that pump on. Wait a minute. LED on and off. I need to just recheck my tool. It helps to know your tool. Okay, go back to 14. Okay, that's why it was lower. All right. All right, cool. I was nervous about this tool for a second. It's just, it is operator error here. Let me let you see it just in case you couldn't. When I turn this on, you can see I'm getting a full 12 volts on that now. I was pushing the LED button. Forgive me, I'm not really sure what the LED does, but it's lower. That's that 10.48 number. All right, so let me let you see what I was doing. Hopefully you can see both still. I was concerned, let me back up. When I measured the load side, when I measured this side, reading battery voltage, 12.3 on the meter, and then when I hit the, or when I go to the load side pump contact and I hit the button, I was only going to 10.4, so that's showing 10.4. Well, I was using it wrong. Look, LED, or on, flip it on, look, 12.32. So no drop in the tool is fine. Leave it in the on position, clipping my inductive low current probe around this to get another pump measurement. And this circuit is pretty much dead. I have no current flow at all. There's multiple ways to go from here. Some of you guys mentioned you like to do ohm checks from the fuse box. That's fine if you want to do it that way. Me, I've seen too many variables. Last step in this process, you guys have seen me do it before. I got to get underneath this, check my pump power and ground. I have the circuit loaded right now, which makes me feel good. Nice thing about this tool, I got to go underneath the car now. Another thing we could do is maybe beat on the tank, which, you know, that's proven to be effective too. So why don't we try the beat on the tank method first? Watch the fuel pressure gauge. I'll go beat on the tank. Just heard the pump kick on. What kind of pressure we got? Nice. That's cool. That's good enough for me, man. I don't really need to go nuts with this. As far as amperage that I'm drawing right now, let's zero the probe out. Get another reading here. Flip our amp probe around. I have 0.37, 0.39, that's 4 amps, almost 4 amps of current flow. I'm totally okay with that for this system. It needs a fuel pump. So that's it, that's number 2 for the day. Fuel pump, definitely want to do a fuel filter. Do I need to crawl underneath this? The reason I'm not going to in this case, 0.37, that's 3.7 amps of current flow to this pump. I saw 3.9 there a minute ago. So just about 4 amps of current. You got a power or ground problem to this pump. You're drawing 4 amps of current flow. Guess what? You don't have a power or ground problem. Me beating on that tank also proved brush contacts in the pump. I know you can have bad contact above the pump in the sending unit area. That's always an option, but hey, that's a check that needs to be done when the tank is down anyway. So pump and filter on this one should be good to go. Really I could let you hear the car start too, I guess, as a final for this. And I don't expect this to run very long. I'm reading 0.46 of an amp now. Let me get you a shot of that. I hope that's showing up. What do you guys think? Almost 5 amps of current flow. I do not need to check this for a power and ground problem. Love the amperage measurement. Love this tool. Again, for you guys that don't know what it is a U-scope. No, it's not, sorry. It is a U-activate tool. It's called a U-activate, and it is from aeswave.com. That's money right there. I'm done. It's like 20 minutes of filming and really 10 minutes of work.